Hello, everyone, and good evening. Welcome to episode number 5 of the series of Amiga Assembly. Let's make an Amiga game. As you can see, all I ask is that you put a like on our videos and subscribe to our channels. Please subscribe to our YouTube channel, put a like to our videos, follow us on Twitter, Instagram, and Twitch. Like our Facebook page, and if you need any help, there are two places where you can reach me, and that is Discord. Join the Phaze101 Discord channel, or come to Telegram. There is also a Telegram group. Here you can you can see our Facebook page, okay? And if you like us so much, you can also subscribe to our Patreon channel or Coffee. Okay, you can support us there. There are benefits, not just these videos. There are other benefits where I share code in Patreon or Coffee. Telegram is our latest addition. Okay, so you can follow us there. And note also that I share this page. Okay, you can have it by typing exclamation mark book page, if I remember correctly. Let me type it. Yeah, there it is. And you get access to this page where you have links of things that can teach you assembly. I've composed this myself, and it is with aim for beginners. Do not expect advanced things here. It's aimed for beginners and what you really need to start coding on the Amiga. The game that we're trying to build up. Ignore that the instructions are in Italian, but the game is a Commodore 64 game that somebody, a friend of mine, I'm saying somebody, Massimo Bonucci, who I think, he wrote it for the Commodore 64. It's a simple game, but when I saw it, I said, this is the perfect game to teach assembly on the Amiga. Hence why I decided to use this game. As you can see, it's a very simple game. You have this character, and you need to avoid the obstacles. You cannot stay for long in the middle, so we're trying to do that. It cannot be more simple than that by having just a sprite. You have the energy bar. Sometimes you cannot avoid them, okay? But you cannot stay for long in the middle. And you have how far you have went, okay, till you get, I think, to another level, because even I don't know what happens when you reach the top of the depth. I have never reached the full depth. So I hope that this simple game helps you in learning the Amiga using some simple routines or routines that we've seen in the book. Okay, I'm not going to continue to play it with to play it. You have seen enough. Actually, let's put it in the middle. It dies when it's in the middle. As you can see, it falls faster and then dies. Okay. Um, we are not far away, to be honest, from having things coming up at him right now. I'm just going to move our game. Okay, go to our browser. Give me a second now. I need to set the screen so that we are in Visual Code. Go. So I'm going to remind you what we did by running it. As you can see, I'm running the extension that I said. I do not have any Amiga configured. I will just run it and you're going to see the game, what we've done so far. I need my joystick. Okay, so far we have our player that is able to move left and right. If anyone wants to do the graphics for the game, please get in touch. These graphics, I mean, it's Hound Dog and myself that did them. They are not the best, but for the game, it serves the purpose. It's not to be, um, you know, something glamorous. Let's put it this way. What we're trying to achieve, it's more the concept of programming. Okay, so I remind you also what we have where we have arrived in with the code. So we have our initialize the screen, the bit plane that you saw there, and the colors. Initialize our sprite. Then we have the print info where we have Phaze101 written on the screen where you saw Phaze101 written. That is this print routine. We will use it to print high score, etc. Okay, and other stuff, text basically. But for now, it's just saying Phaze101 just as a text. Then we have a loop, okay, which I will discuss if you remember, because the joystick was too fast moving the player. I had to delay in frames what we had on the screen. Then we have read joystick and we move our player. Okay, so today we're going to expand on this. Okay, and we're going to actually build the game loop and start doing routines related to the game loop. The other thing is I will try to list what goes into the game loop, but of course I will comment them out and then we will start doing them bit by bit. Hence, it will give you an idea, okay, what comes next or what we need to do next, okay? That's the, let's say, the aim of the game loop. But first, before we go there, okay, we need to do a change that I did it temporary, but now it needs to be done the proper way, basically, and that is having a routine that updates the player. Okay, because right now updating the player is part of the main routine, the main loop, which shouldn't be. So, having said that, I'm just going to do my usual copy and paste. And let's create the routine that updates the player. So basically, we are just going to move it right now from what we have, okay? And this is so here is our routine. This is updating the player. So we're going to remove it from there. And have a routine called update player. And it should end with RTS, no? In this case, I'm just going to do a small thing just to remind us, okay? I'm just going to do basically this, okay? Oops. I wouldn't normally do it, okay? It's to help you out when you're reading the code and not to scroll up and to remember what the routine needs, etc. I am inserting as much comments as possible so that you know what it needs. And in this case, update player needs the parameters of our move sprite now. So I added them there so that you remember them and make life more simple. I mean, this code, I'm writing it with the aim for beginners. So I try to comment as much as possible what it does. Now, that's the player routine. And since we moved it from there, we need to go back to the main loop. And now, instead of this, we do update player. Okay, so for now, we have read joystick and update player. I am going to leave these frames for now. I'm not happy with them, I have to admit, but I had to create them because there was nothing in the game loop. So the game was too fast, and hence I had to create some sort of delay. Eventually, we will just use this one, okay? But for now, it is acceptable to use them. So this part, what we have there, we need to think now what goes into the main loop or game loop. I like to do this first of all to remind myself that the game loop actually starts from here. This I would have done it whether I am on a live stream or not. Always indicate when where are the routines of the game loop. So what we need in the game loop, I'm going to skip these and we will write them down here. So we need a way to respawn enemies, no? Or objects or whatever. So somehow I'm going to call it update respawn. We also need, so that is to respawn enemies. So basically, don't think always the things happen on the screen. In this case, the respawn is going to happen in memory, okay? Then we need to update what we have in memory to the screen. So then update enemies on screen. Enemies. Let's see. So I might get these wrong, okay? I'm just thinking ahead what we might need. We need somehow to animate the player, because that I do have the animation of the player. I haven't yet added it in the code, but we do have animation for the player. So update anim. We need to check for collision. The sequence can also change, okay? So it's more right now to see check collision what we need. What else? We need a way to update the score or update the HUDs. So actually better to update the HUDs. Right now there is others like, you know, end game, end screen, etc. But for now, let's concentrate on the main game. These are parts that are related to the game. You know, we need intro screen, etc., game over, and stuff like that. But these are the main ones. So now I'm just going to comment what we did here, and I'm just thinking if there's something else I need to organize before I even start coding these. So one thing that we need, and I mean these two are the copy of each other. So I'm on the left side, I'm keeping the main loop, and I'm checking how we're going to do this. We need variable area, no? Every game has variables. So we need a variable area. Because we have our variables right now are scattered. and I do not like that. I like them in one location. Yeah, so I'm going to make them at the last part. Yeah, I'm going to make them here, the last part between in the same section where the code is, because it's okay to live with the code. They are okay to live with the code, and they do not need to be in chipmem. So just before the code related to chipmem. Another thing, note that I am using one source file right now, except for the include file, which we have here, the startup file, where everything is in game.s. Okay, I have included snippets, which I'm hoping to include. I mean, we included most of them except the two which are green. The rest we have them. Okay. But if we don't today, we'll see where we will be. But I have included these snippets. I'm including the snippets so that in the next episode, I will not be sharing the code, but you can continue from where we live today. Okay. It's not that you start from zero. So let's create a variable area. Okay, so one thing I want to do is group all the variables that we have scattered around right now already into one area. I'm not referring to constants. Constants will remain at the top of the when at the top before the game starts. Okay, but variables, we can have them anywhere, and I'm going to move these. So I'm going to skip this for a moment. I already broke my own rule there. Okay, so this one, these two needs to move. And what else we have? Okay, those are the only two that we have right now. Now, I need to think because I need some type of structure. Okay, and I will explain why in a minute. So, let me bring the my OneNote. Sorry, not OneNote. My tablet, my whiteboard. Okay, so we need to do something like this. So the Amiga can have 8 sprites, no? We have 1 for our player. We have 1 for the player and 7 remain. However, I want to skip 1 and I want to have 6 for enemies. Remember that Amiga sprites are paired also, so that means they share the same color. So sprite 0 and 1 have the same color, 2 and 3 have the same color, 4 and 5 have the same color, 5 and 6 have the same color. I'm always talking when you have sprites, standard sprites, which can have three colors and one transparent. So that's why I am saying that. Now, since we have 6 slots where we can have 6 slots where we can have our enemies, okay? So remember, a sprite has got a structure. In the Amiga has got a structure. It's made of V start, H start, I'm not writing exactly as they are written in the manual, but and vstop, and then our special byte, okay, or control. Actually, let's call it control byte. It's better. Each one of these is a byte long, okay? Then we have our data, as much as we want, okay? Depending how much we say in vstop. If in vstop, the difference between, let's say we start at 100 and we say 116, then the sprite height is 16 pixels high, okay? So, and then we end up with the word, okay, 0, 0, 0, comma, 0, 0, 0. We have 6 of those, okay? 6 of those for our enemies. But what we put here, okay, the data, okay, can be infinite, okay? Can be as much as we want, n, okay? So I do not want to limit myself to have just 6 different sprites on the screen. I want to have as many as anyone designs. So if you guys help me and design sprites for the game, I want to include them all, basically, if possible. So what we need is, so this is a structure by itself, okay? It's the Amiga way of having the sprites, but we need a structure where we have our data. Let's say we have, I'm just going to say object 1, okay, object 1, then 2, 3, 4, 5, 6, 7, 8, 9, let's say 10 for now, okay? Each one of these, okay, has got the data for an object, okay? So what we need is to have a table, okay, that points to each object, okay, to each of our objects, where it will have the address of object 1, okay, 2, 3, etc. till 10. And we need a way of controlling this. So what I mean by controlling this is that each, so actually let me revert back. So we have the data, okay, for each sprite here. What we do is copy the data. Let's say we want object number 3. We copy the data where the sprite data is for the structure. But how do we decide in which slot it goes? Okay, so basically here I'm just going to, now I'm not going to mention everything here, I'm just mentioning points. Okay, we need this type of structure, okay, that tells us, okay, slot 1, I'm going to call them slots, okay, okay, do we have a sprite there? Do we have a sprite there or not? So if it's a 0, then it's a no. If it's anything else, 1 or anything, then it's a yes. Okay? Then we need to know, because we're going to move this sprite, we need to know where the x value, what the x value is of the sprite, and why I am not using what we have here in the sprite structure, because I want values from 0 to, not to 5, but more, and then let the sprite routine control that. So we will have, say, then another byte which says, sorry, word which says x and y, okay, and then we want also speed, okay, so how fast is going to scroll up, okay? Because if it's in the middle, it's going to scroll faster than if our player is in the middle, the sprites are going to scroll faster, or the enemies are going to scroll faster towards the player. So we need some kind of structure here which have these values. Sorry, I'm being in a way high level. You will see it in code, but I think it explains what our aim is of how to build this structure for the game. I mean, to be honest, today once we build this, it will be, I mean, this is the let's say the focus, the core of the game, what we are doing today. So I consider this episode as one of the most important from all that there will be in the series, because we are actually constructing the structures for the game. So I'm just going to minimize this and go back to our game. So let's do this as sprite player x, y, okay. And that is the block for it. Normally, actually, I want to do it because we're going to have many. Normally, what I do, I divide these instead of double lines, single lines, and I do the same thing. I'm quite obsessed with neatness of code, and this is why I'm doing this. So now we need the structure. So these are all sprite variables, but I'm dividing them into sections in a way. This should be capital. You can see that I'm picky about it. Let's say it's my Odyssey, no? So we need how are we going to do this sprite? I'm just thinking how I'm going to construct this sprite structure, you know, the data structure or tables. Actually, let's divide, yeah, actually, let's divide tables from just variables. So this is game tables. Okay, so we need a table, yeah, that points to the sprites, to the sprite data. Okay, so enemy sprite table, and this will be table of sprite. And it's quite simple, okay? It's not that there is define constant long. And if you recall, I renamed each sprite structure. So this is a point. These are all pointers to our sprite structures, okay? In the Amiga sprite structures, okay? Oops. Sorry guys, because of my hand, I need to copy and paste. I'm quicker like that. Five, 6, 7. That's the last one. So these, okay, I'm going to show them to you. I'm just going to go on this side. So we have this sprite, the first one, as you can see, okay, I called it sprite 0, and I have all the structure that makes up a sprite. Okay, this was always there. Okay, we started this from the beginning. So we have all of them. You see, we have sprite 2. These are the enemies now. Sprite 3, sprite 4, sprite 5. So I'm going to point this table to all these. Okay, that's what I did there. Now we need a table which we do not have yet. We do not have the data. So what goes, you see here, I'm define constant block of 16 times 2. That is, our sprite is 16 pixels high, and each sprite, remember, is 2 words. So that's why it's 16 times 2. And our definition is word. Hence, we do not have the data that goes here, but we can still create the table for it. So I'm going to create enemy image sprite. Now this one I have included in the snippets the data for this one, but I do not remember the names. So let's first import, oops, not here, but in snippets, and we have sprite data. There you go. And we need, this is, as you can see, okay, it's divided in two. Here we have the animation, okay, for our player. Okay, so this is what goes copied into this sprite structure for the player. And then we have the sprites, different sprites that we can have for our slots, the 6 slots. I have 7 here, and we only have 6. So definitely we have more than 6. And the more you give me, the more I can do. So I'm just going to copy these, okay, and I'm going to insert them just before the GFX data. Actually, we will be copying these. So actually, none of these need to be in chipmem because these will end up to be in chipmem. We do not need to do that. We can have them just after our tables. So because we will be copying these, we'll create a loop, we'll create a routine that will copy this data to the structure. So okay, so now I need to remember the names of each one of them. So let's go back to, I can close this now. So let's go back to the enemy image sprite table, and we define constant long, and we start taking the names of each one of these. So same thing, but number 2. I'm just trying to use the mouse because I think I can be quicker. So if any one of you wants to draw any GFX, I recommend the program of Aussie, which I will show you in a minute, just to remind you. Okay, so we have the table with our, this should be data, image data, table of sprite image data. I know that I said we have the animation of the player. I'm skipping that for now, because we need a routine for that that will handle all these. We need also the table, okay, that, now this I need to think a bit harder, that has the structure. So we have, let's say, we need an array of objects. That's what I'm trying to create here. Okay, an array of objects. So let's define an enemy structure. And then we create an image for and then we create multiples of these. So this is because this is what we will have on the screen. And enemy I was going to call it enemy object structure, but because it affects the screen, for now I'm going to call it table screen, and then we will see. Okay, but what's important, okay, what we're going to say here. So I will need define constant byte, and this is a 0. Yeah, and this will be active or not active. So active equals, let's say, ff, and inactive 0. Then we need, yeah, actually I missed something when I was doing the on the whiteboard. We need in which sprite this object is, in which sprite structure this object is. Okay, so we'll call it 0, but here we will have actually no, what we will have is the enemy that we are showing. So the enemy image data. Which one? Which enemy image data we are showing? Then we need actually this will be a word, and this will be the y, the enemy dot y, and this can be for now, okay, between 0 to 256 255, sorry. Then the x value, and the x value doesn't need to be a word because we are only moving in 3 positions. So, and we need this so that we know in which column, let's say, we are putting our enemy. So this is the enemy dot x. It has only 3 positions basically. That is it. Now this gives us 5 as it is, 5 bytes. That means first of all we need to use the directive even to make sure that we align everything. But what we actually need here is, because we need a block of this, so define constant block dot byte, and we need this table can only be uh, 6, no? I'm going to create a constant. Yeah, I'm going to create a constant here. I'm not going to put anything, but this will be maximum max enemies. It's a little bit too long on screen. And it is too long. Anyway, let's do this for now. And let's do 6. No, that's the maximum that we can have. I am thinking if this is right or not right now. Yeah, I think it is. Yeah, so you realize that when you are doing a game, okay, you realize how much time you spend thinking, okay, more than actually coding, in a way, okay, unless you had planned it again ahead. But I haven't. I just know what I need to do, and I'm trying to be in your shoes, okay, um, and doing, like a beginner, trying to reason things and doing things as we learned, okay. So I'm just going to do something here, and this is my Odyssey, okay, so that they are all equal. Also, so that your code will, I mean, I want you to be able to read the code, okay, so this is why. Also why I'm using long names such as these, as constants or as variables. Normally I don't use such long names, but I want the code to be as readable as possible, okay? That's the aim behind it, so that you learn. So this should be times, why didn't I copy it? So let's go back and I copy it. And then let's go down and add it to our table. So times, and then we want them to be initialized at 0. So now that we have that, okay, we do not need this. But what I'm going to do, okay, I'm going to change a bit so that we know what we're going to have there, why we have done it. I'm going to create comments. As I said, I am thinking in your shoes, okay? So this one is 1 byte. This one is 1 byte. This one is 2 bytes. And there's a reason why I'm putting the numbers, because, and this one is 1 byte, because eventually we will be calling, we will have a base address, let's say in80, and then we'll be adding these values, okay? So this should be actually 2. So this is 0. This is 1, yeah. This is 2, 3, and that is 4, byte 4. Okay, and we will say what each one of these does. So I'm going to say here, I'm just going to call it enemy dot equip, okay? This one, enemy dot enemy. We can call it data. Which data we are pointing to? This one, enemy dot y, and this one, enemy dot x. So I'm just going to change these to hyphens. That can be, and this there can only be left, middle. The variables, okay, which we already defined, and the right. So those three constants, we already defined them. So we will have these. So these are 6 that are active, the maximum that we can have active in one time on the screen. So that's another thing that we've done. So I'm just thinking if I skipped something here that even is very important. Okay. So what's next now? Okay, so we have our structure defined. We need yeah. I'm just thinking that I have lots of things in my head. I'm trying to think which one I should go for before we continue, because I do not want to confuse you. Okay, so we said about the structure. Let's where is our main loop? Here. So far we should be able to, okay, still have the code executable, and let's check it just in case I made mistakes there. Let's run it. Oh, no mistakes. So we should see the same status as we had before, but we changed quite a bit the code now already. So we should still see what we had before. So it's still the same, and it's still printing, you know, where there's Phaze101, it's still printing there. As I said, that's just a test. So now we need to eliminate, okay? I need to eliminate those. By the way, I still have the test for the left mouse button. If we press the left mouse button, we exit from the game. Normally, you don't have a way to of exiting from the game. I have it for us to be able to check things. Okay, so eventually this will go, but for now we need it in a way. So I am not quite happy with these. Okay, there should be a way of eliminating those. Now the thing is, should I eliminate them now or not? Because I do not have yet. I do not have yet the enemies displayed. So should I do that? Also, there is no animation, but it's fine. Um, Actually, let's leave them there for now. Let's leave them there because it's not going to create any issues. We will then remove them. I think let's do the update respawn. I think that's the best one. Let's have an enemy on the screen. I think that's the best way to approach this. However, we need a random routine because we want them to appear randomly on the screen, not one after the other, as they will stop. So, okay, let's add a random routine. And for that, I use the help of EAB, okay, and also some help that I did some 30 years ago. So I have two routines, okay? One I called it random A and the other one I called it random B. I'm going to include them both. This one I had time to test. It works, but it's not the best one that you should um, use when generating random numbers for the Amiga. However, it's quite short and it's quite fast. This one I have written it 30 years ago, and as I have notes about it, but don't ask me right now what it does. I do not know. I'm being honest. I do not know how it's getting a random number in the zero, but it does it. Okay. To be honest, I'm going to include them both in the code, but I'm going to use this one. Okay, because this one I have tested and I know what it does. Eventually, I prefer to have this because this I know that it will work on any type of hardware, while the first one might fail. So it's why I am cautious about it. Um, so I'm just going to add them to the code. This is the only research I did before this stream. Okay, so I'm literally I did how to generate random numbers, and there were on the EAB board. There are so many. The topic is quite huge. I know that when I coded this, I used I don't know, some type of mathematics or something that at that time I used to know. Now, don't ask me. I'm bad at mathematics. At that time, I was better, 30 years ago, and it's following some university, how to generate a random number. But I really, I do have notes about it, but I really do not know. It's me 30 years ago trying to talk to myself and say, what the heck have you done 30 years ago? So that's a reality. Let's add it to the to our code. I really do not remember. And one thing that I didn't say actually, and that's the funny thing about it. I noticed these comments of mine. These were written by me, okay, 30 years ago. I know why they are there. This routine, originally, I wrote it for the Commodore 64. I converted it for the Amiga, and I kept the same principles of using the X and Y of how to generate the random number. That I know. Unfortunately, the routine for the Commodore 64, I do not have it. I lost anything for everything. But for the Amiga, I still had this. So that's a bit of history about it. So let's add it to random numbers. Let's put it here. Let's put them here. I'm not going to put the constants that this routine uses in our code yet because I haven't tested. I prefer to leave it there. I know it works, but it's not really tested. While this one, I have documented it, and where you will find things related to it in EAB. Okay, so I even discussed this with Photon of Scoopex, and he really was against it of me using it even in here. But I said for now it will do. But I do agree with him. I should be using this. So, but for now, let's use random B. Now, so let's have that was update player. Let's do the respawn. This should be in it. So we need a way of initializing some timer before we spawn something, and that would be a random number. Okay, so init respawn. Okay, it would call our random b. Now this one, I do not want low numbers. I do not want small numbers. So let's say if it is lower than 100, we ignore it, okay? Because as it will be, they will be coming too fast towards the player. To be honest, I'm guessing this 100, okay? So I'm not sure if it's right or not, but let's say anything that is lower than 100, we go back, okay? So, and we call the init respawn again. If it's okay, then we need a variable where to spawn this number that we got. So move the 0, 0, 3. And that is all. So imagine like we have a timer, okay, in the 0, and we are storing it in respawn. Now that timer will be how many frames we have to wait till we create an enemy. That's what it means. So if I put this 120, if we have 60 frames per second, that means I'm going to wait 60, no? 2 seconds, sorry. That's how basically I am controlling it in a way of how to display an enemy to the screen. Right now, as I said, it is all in my head. I mean, I don't know how to explain it, but it is my high level thinking. So on this side, where we have the data, we need a respawn variable, or respawn timer. That's what it is. We call it respawn. This should be and be a byte. Is this? I'm thinking if I'm thinking right now. It needs. Let's not make this mistake. Okay. It needs. It needs. Even no. Just in case. I'm going to separate things. Okay, so now we need another routine that decrements the respawn. So what shall I call that, and what shall we do that? Uh, so I think that the naming that I use is wrong. This is a timer. So, and the other one is we're going to update it. Yeah, that makes more sense. So this is update respawn timer. So every time we do a frame, we decrement this timer. That's what we need to do. So update respawn. And sub quick immediate one comma. When you're using this expression, okay, we called it respawn. No, one thing that Vazim is really not forgiving. Okay, doesn't forgive is the capitalization and lowercase, and you need to type exactly. I mean, in as in one, if you type one lowercase and the other one uppercase, normally it's okay. But in Vasim, it is case sensitive, so be careful because you'll get lots of errors in relation to that. I'm still myself starting to get, because before I was using always as in one, so I'm still trying to learn, let's say that. Wasm basically. So branch or not equal dot s, and we should have a label exit. Now, if we went to 0, we need to call it again to initialize itself. So branch to subroutine dot word, and we will call init respawn timer, and this is a routine that we don't have yet. We need somehow to populate the enemy table. Yeah, populate enemy. And then we have the exit here. Yes. So this one we do not have yet. The populate enemy table. I'm just still thinking if I'm doing this right or not. Yeah, it is correct. So what we need, I hope I finish what the thing is, if I do this, this is going to take us, I do not want to finish. I want to have this routine finished, and I want, because this will update the table structure, but then we need the routine that will display the sprites to the screen. So we are missing two routines, and Jesus, already 9:30. Okay. We are not yet there. And okay, so here in the main loop now, what we really need, let's see, we have update, we called it update respawn. Let's compare what I called and what we actually have. So we just need actually, okay, so what we need is this one. We need to call it before we enter the main loop, the main gain loop. So that needs to go up here. Yeah. Then in the main loop, we will have our ticker pointer, our ticker timer, sorry, not pointer. Well, that does the update respawn. Okay, so because then, if when that finishes, if you recall, we are calling init respawn timer, so we're calling this one. So only when we initialize, when we start, we need to call it once. Then this one will be calling it anyway. So, okay, so we have added one routine. So now we need two routines. one to update the enemies on the screen, which I already said, but before it we need this one, populate enemy table. Okay. So let's see how we're going to do that. Now this one is quite, it will need to do a lot of checks, this routine. Yeah. And it will need some thinking. Okay, so let's start it. I mean, populate enemy table. So what we are going to populate here, what I mean by populate enemy table. Okay, so if you recall, where is it? Down here. We need to populate, we need to initialize this. That's what it means. So once the 2 seconds has passed, let's say, okay, so 120 has passed, 120 frames. Okay, if we are at 60 frames per second or 50 frames per second, depends how you see it, which one we are on. We need to initialize our structure, this structure. We need to start populating these. So we called it populate enemy table. So now we need so let's do LEA. Definitely we need this. Enemy table string, comma and 0. We need the pointer to it, no? Then we need to check the first one and check is it active or not. If it's active, we ignore. Okay, we skip it and we go to the next one. If it's not active, then we populate. That's what we need to do now. So move byte into the 0. So is it active? So branch on not equal s, and let's call it not empty structure. Okay, the structure is not empty. But if it is, we can populate the structure. Okay, so okay, this one is we need to call branch to subroutine again to our random number. And whatever the answer is, I'm only interested in the lower so far we have only 7, right? So in the lower nibble. So we can do, so basically I'm making sure that end is zeros and only the last 4 bits or 3 bits, sorry, are affected. Okay, so 1, 2, 3, 4, and then 1, 2, 3, and 7. 1, 0. I will comment this later on. Okay, so right now I am just thinking what I need to do. So we got a random number. This number will give us this number will tell us which sprite we're going to display. Okay, which, you know, we have different enemies. You know, we have, let me remind you, we have all these, no? So that number, we're going to select one of those, and we are going to put that just thinking about the logic. Hold on, we are missing something here. Yeah, we have a structure here, no? And we have 6 of these. We need a counter to tell us which one we are in. So, okay, so move, because we're going to loop through the whole structure, no? Till we find one that is empty. Imagine that they were populated and we were taking off. So yeah, let's do that. Now that number, so the reason why I use the 3 is because I'm going to destroy the 1 which we will use right now. So I'm making a copy of what we have in the 3, the 1, because we're going to loop. I mean, I need to preserve the 3. Then LEA, the enemy sprite table. Yes. So we're going to get a pointer to this now. Yeah. So and we do that in A1. Sometimes auto completion is a nightmare. Okay. So, okay, so if we are 0, it's fine. But let's say we are in the sixth, sorry, let's say in the third item of this table. That means the third item starts at 3 times 5, no? Because we have 15 here. So each structure is 5 bytes. So I'm trying to understand if my thinking is correct. Okay, so how shall we do this? If you do not understand something, or please do stop me, okay? I mean, I'm not going to bite. Actually, I like people that interact and ask me things. Hold on. Yeah, we need, if let's say we are in position 3, okay? Okay. It clicked off all of a sudden. So my reason was, let's say we are in position 3 of this structure, okay? But the pointer for it is here. So each one of these is an address of 2 words. So we need to multiply by 4. So let's say we want to know the address that we are using for sprite table 4. Okay, so to find the address of this one, we need 3 times 4. Okay, so we achieve that by doing lsl.long, and 2 is 4. Okay, so we are shifting to the left, so multiply by 4 the value in the 1. And then we move what's in A1, okay, the enemy sprite table, comma D1, okay, into D1. So that is the address. Let's say we got this value. Remember, this is the structure of the sprite. So SPR4, we're getting the address of this, okay? Let's say it was 4. We are getting the address of this. And remember, we need to populate this where the data is. Plus, we need to populate also these, you know, the V start, H start, and V stop, because we want them to be seen on the screen. This is going to take me longer than I thought. So in the 1 right now, we have the address of our sprite structure, Amiga sprite structure. So Let's see. I need to look at the variables at the, as I will, because I do not know them by heart. So in our copy list, we should have, let me see if I'm right. I should be right. In our copy list, yeah. So now we said it's going to be, let's say, number 4. So we need to populate, okay, the structure of sprite number 4, okay, into here, okay, into the address. So we need to update what we have in the what we have in the sprite pointers with our sprite structure. So LEA enemy, yeah, enemy sprite pointer, yeah. Jesus, this is annoying. Once we get that, now we can work on the structure. So again, we preserve the tree, and we move D3, D2. We need that. We need to continue to preserve it. Now, which sprite are we going to modify? Each sprite is 8 bytes. It's so from this pointer, let's say we are modifying this one, okay? To know which one we need to modify, okay? So we need to update the value here and here, okay? There are two differences. So each sprite, if we had to count between here and here, there is 8 bytes. Okay, that's 2, 4, 6, 8. So to update the next one is 8. So we need to multiply this by 8. So lsl.l 3 is 8, no? Comma d2. And then because we have the address, so now we are going to store the address of the sprite structure into these two words. So now we got that, no? So now we are going to do move.word d1, yeah, which is the value that we got here, comma 4 bracket a1 comma d2. Then we swap it. So this is the low byte. Now we're going to update the high byte. So swap d1 move.word d1 comma, I can do this a1 comma d2, but fourth, since you are beginners, I put at 0, okay? Just to make sure that we are not. So here we updated the high byte. So we start here and we start here. Actually, first we start here, the low byte, and then the high byte. Sorry, why I'm saying byte? Low word and high word, okay? So, and then we got it back. We need to get it back to what it was. Swap T1. Okay, now remember we have this sprite. This is easy now. We have the structure and we need to populate it with the data. So we need to copy one of these, whatever number we got. Let's say we got number 3, okay? This is number 5. Let's say we got number 5. We copy this, that random number produced number 5. We copy this into that data. So we need a routine that does that. Well, a routine. We need a loop that does that. Given that I'm not am I skipping a step here? No, it's correct. So LEA enemy init SPR table. Okay. Sometimes completion does help. And we use A2. We need to get this spread data that we need. And remember, each sprite is made up of 2 words. Not 2 words, the data is in 2 words. So we have the image. So enemy image sprite table. Enemy image sprite table. Yeah. And we have the pointers of this. Now, and we also have in the 0, we also have in the 0 the value that we got from the random number. No? It's here. That number, let's say we got, I don't know, number 2. So to know where the data starts, we need to multiply it by 4. So let's say we got number 2. So number 2 is this one. Okay? To get the value, the address that we have stored here for toilet paper, okay? We need to multiply that value, digit 0, times each one of these is 4 bytes, no? By 4. Hence, what we did before, so we need to preserve the 0. Again. D2, I'm always destroying it. I destroyed it here, so I can use D2 again because D1 is the address that we need. So, and then multiply it by 4. I could have used multiply, okay, but I prefer LSL because it's faster and it makes more sense. And then we need to move that value into A3. So the address that we have in enemy sprite table, one of these, let's say the address that we have stored here, we need plus what we have in D2, we need to add D2 to it, we need to move it into A3. Okay. Now, this is going to be for documenting it. I mean, I will document it offline, okay? But I will document it because this can be confusing. So we have the image sprite table. We need where we're going to copy it. So the 1 holds that value. The 1 is up here. That's why we preserved it. So move.long p1, a1 because it's an address at the end. And we need, because I cannot just copy it there, if we recall, okay, if this is a sprite structure, okay, we need, the data needs to go here. So we need to skip the first 4 bytes. So we need to add 4 to that value, to that address. So add quick.long into A1. And now we can copy the data. So move quick.long. We have 16 minus 1 because we will loop to 0, comma D2. And then we need to copy the image data. So copy image sprite. Okay. Now it's a simple move.long. What we have in A3 plus yes to what we have in A1. So source is A3, destination is A1, and then increment branch. In this case, it can be, there is no branch. D2 comma dot copy image SPRL. Still we haven't finished yet. We just copied the data, but we now need to set up the bytes, that the first 4 bytes of the sprite. So, and also the structure. So H0 points to our enemy. So H0 points to here. Where is it? After this, between this and this here. H0 points to here. Points to here. So we now need to populate this because we haven't populated yet. So we know that the first, since it's going to become active, the first one is move.byte. Come on. FF, comma, yeah, H0. Then move.byte. This is which enemy number. Yeah, enemy number. So I'm not sure I named it correctly there because I called it enemy data. That should be enemy number. Okay, so we had a mistake, but it's still fine. Did 0, comma 1 bracket and 0. So what I mean by that, here I call this data. Which data? But actually what we mean by data is which enemy. I mean, we are not interested in the data, but which one. Okay, then that number gives us the data. So this is enemy number. Actually, let me write it in full. So here we moved what we had in the 0. Remember, we got it from the random number, which one, into A0. Of course, 1 because it's byte number 1. Now, okay, this one, we need to set the Y. Now the Y, they will always start from the bottom. For now, it should be 256 plus 16, the height, or 255 plus the height. Plus 1 to hide it, because as it will be shown the first line, into 2, 80. So far we have populated till here for this iteration. We have only done one, okay? We are not really looping, and actually we can test it, I think, like this. Then x. How shall we set x? How shall we set x? Because x needs a random number. So we have a routine called where is it? This is to move our sprite. We don't have it actually. Hmm. So we are missing one routine to display them on the screen, because right now this is all happening in memory, creating a structure. Then we read the structure and we display them to the screen. But we are missing another routine, which is to decide in which column, which position the X is going to be. For now, I'm just going to be pathetic here, and I'm just going to set a value, but I know I need to actually, let me make a comment. Yeah, I'm missing the routine, so like that I remember. Set sprite X position, and then I'm just going to pass an immediate value for now. Move dot. So basically, set sprite X position will decide whether the enemy will go into the left side, the middle side, or the right side. So I'm going to say middle for now. Okay, so it will collide with the, and that is 4, X is 4, right? This position 4. Yeah. So 4 bracket 80. So we populated the structure, and if we populate the structure, we are missing something, but which we did in the beginning. This should be exit here once we did it, but here I mentioned this not empty structure. So it's not an empty structure, but this means I'm going to create a loop. We need to jump to here when it's not empty. And then, and like this is how we create the loop. So down here, we should have exit. And I know I superseded the 2 hours, but I'm just going to, I want to finish at least this routine. We are going to end up without having this routine the way I wanted, because we are missing 2 routines. This one is set sprite X position, and actually to display the player to the screen, the enemy to the screen. And this one will have RTS. But if we loop it, we will need to add, because our structure is 5 long, no? So add dot quick dot long, quick long, immediate 5, comma 80. 80 is, remember, it's 5 bytes, this structure, so that's why 5 there. I promise I will document it, because it's too much, and I don't even know if it's going to work. So my logic here is add dot long, quick dot long, and we need to add 1, yeah, to the tree. Why 1? Because we start from 0, so we're going to have, as I said, an array of these, no? So we go of this object. So we go with array 0 and we check where we are. If this was populated, we skip to the next one and we increment by 1. If we increment by 1, okay, we have added the structure, okay, 5. So we are in position 5 now. And that's why we increment this by 1, because we know the maximum that we can have is 6. So once this one reaches 6, then we have, let's say they are all on the screen, then the timer can initialize as much as it wants. The respawn timer can initialize as much as it wants. We will not be able to populate more sprites to the screen. So that's when it will not happen. But it's here where we decide. So we add 1 to the 3, then we compare dot long, yeah, with the, did I make it, with the maximum enemies on screen? Did I make it a long? Because it would have been better if I took compare dot long. Yeah, comma the 3. So maximum enemies on the screen. Oh no, it's fine. This is 6. It's telling me it is 6. And the 3, where is the 3? I initialized it as long. Yes, that's fine. So now, if it's populated, we incremented these and then we need to loop. But where do we go? So now, where do we go from here? I guess here. So yeah, let's call this next struct. And we have populated, yeah. Okay, so we are missing this routine and we are missing, so populate enemy table, we can say we have it. I mean, I will not, but we populated this table. Now we need another routine that goes through this table and display to the screen. Why I'm using this type of thing, why I'm using the structure, so that here we can have as many sprites as much as we want, okay? And this, imagine we, instead of using sprites, we are using bobs. Bobs, we can have unlimited number of bobs on the screen, or as much as the system permits. So the same rules for sprites apply, no? We can have as many bobs as we want, we can track them through such a structure, and we can populate the structure, okay, or whatever we have for this, for the bobs using such a table. So this is where the data for our sprites is. This is where the bob structure is, if you want to call it that. In this case, it is the sprite structure. And this is our structure that tells us information about these. Okay, because we will be querying this quite a lot. Where our sprite is, so then we increment the y, where if it's active or not, we are already doing that, and which data we have, okay, which enemy number we have in the structure. Let's say we want to have power-ups, then if we have power-ups, then by the number we can tell which one we have. And this is why I opted for this. For this type of let's say, structure of the game. I will comment this. I know it is, I mean, you heard me doing it, sure, but I know that you will need comments to get it, to understand what's happening. But of course, you need to watch the video and the stream to understand it. Yeah, it's I wanted to have, I didn't think it properly, okay? I wanted to have this ready and what we have here ready. So I might, although I said this is the last stream that I will share, maybe I will share the next one too, because I feel I'm leaving you in the middle of something. So if we go to the here, okay, now we have the update respawn. We are missing this. This one will go through the structure and update, puts the sprite to the screen according to the structure. But this structure gets populated by the routine that we called populate. What did I call it? Populate enemy table. Yeah. Okay. So forget what I said. This is not the last time I'm sharing the code. I will share it next time. It's a shame that I'm finishing my streams with the code, those two routines missing. We will continue next year, or I don't know, maybe I will surprise you and do an extra stream till the end of the year. I don't know, but it's very tough for me to do streams in the next 2 weeks or so. Okay, so I thank you all for listening to me and wish you happy holidays. So thank you very much, guys, and see you next year unless I surprise you with another stream in relation to this. Thank you. Wish you happy new year, happy holidays, and please be safe. Okay. See you and bye bye. Bye bye.